welcome all to this stream. This is the first episode of a new series by Ozzy related to the racing car game jam that Phase 101 and Retro Programmers Inside are organizing. So, let's welcome Ozzy.
Hello everyone. Thank you, Faith, for having me after such a long time. I was busy the last 3 weeks with my life. I had this strange thing we have in Italy. It's called the picking olivi. And then my vampire card broke down. So everything happened the last, let's say, 10, 15 days. And I didn't have much time to spend on Amiga programming. But anyway, I hope now it's much better. And I know that I'm supposed to do demo coding, but I decided just for a little bit of time to move to something else because the last let's say it's not a competition, it's a game jam interested me a lot because I had this desire and always had this desire to try to make a card game. And I think also that all my routines that I will use on this card game will be reused, of course, for a demo. I'm pretty confident that my code is flexible enough to be reused in other productions and in other demos because I think vectors and all this stuff that we discussed in the last episodes is quite generic and can be used in games, but in demos as well. So I just took, let's say, a try. I don't know how it will go. I will try to do my best as always. I don't know if I will finish the game. For me, the important thing is just to build
You will finish it. You will finish it. Hello, Lolo.
No. Video games are different from demos. And this is why I love demo scene, because when you say it's done, it's done. The demo is done. Instead, in games, you have, let's say, a more or less, there is a clear end of the game. So in order to have a complete game, you must have the menu, the sound, the effects, the game engine in place, so a lot of stuff. Otherwise, the game is unplayable. On the other side, the demos, you can do a very short demo, like my bomb triangle, or you can do a much more a bigger production. But in either case, you decide when the demo is finished. So if you fed up with your project, you can just say, okay, let's close the demo here and move on. And this is harder to do with games. This is my opinion, of course. Feel free to disagree with me. But
they are different. I agree with you on that. They are different, but yeah, a demo, when you finish it, you finish it. A game, there is always a place to improve. No, but a demo also, I think there is where you have to improve. So I don't know. I tend to like more games nowadays. When I was younger, I preferred doing demos.
yeah.
I do not know. It's just that whatever you do, I think there is always a place to improve. That's my take on it. Anyway.
Yeah, for me it was the opposite actually, because my childhood, I used to play a lot of games, especially on Amiga and on arcade, of course. But then, with the adult age, I started to, let's say, to appreciate a lot more digital artists.
Uh-huh.
And of course, a game can be a digital masterpiece, of course, but for me, demos are more, let's say, something that really show off the capabilities of the coder and the graphics, the artist. So I don't know. It's just my impression, probably.
Well, it depends, but yeah, okay. So, as always, before we start, I go and do my usual ritual. So, for now, Ozzy will have to listen to me, and in the meantime, you will be telling me if the sound is okay or not, because this is another thing why I do this.
It's okay.
Yeah? So, please like and subscribe my YouTube channel. This is the only way I know of how I can spread, coding to the masses, to the Amiga, so we get more people coding for the Amiga or for the Commodore 64. Under each video, may I remind you that there are links to either the playlist, because there is always a series, and to the code. Most of the code is on Mega, and you will need to subscribe to Mega to be able to download the code. Please follow my Facebook page and subscribe to my Facebook Phase 101 group, and also to the Commodore Dev Facebook group. Commodore Dev is anything about Commodore. Phase 101 is about Phase 101, of course, what we do. You can write to me on Facebook. I do reply, but I take time. But if you send me a message on Discord, then I'm much more quicker. I also have Telegram for those that do not like neither Discord nor Facebook. You can join there. And then for those that want to support us, you can either join Patreon or Coffee. They are identical, and there are about 70 videos that are logged and only available to Patreons. That can be watched there. Before we start, I remind you the Game Jam. The Game Jam is about racing cars, or similar, let's put it this way, because you can see here this is not a racing car, but it's a car on a platform, but those type of things, if I may say. The deadline has been extended till end of January, so you have more time than what we anticipate. Also, because I'm going to be away, and when I'm away, it's impossible to then stream the game jam stream. So this is also why I had to extend it. We had to extend it till end of January. Also, I realized that maybe, at this time of the year, till Christmas comes, everybody will be very busy. And then when the Christmas comes, everybody will be relaxed. So then you will have time to do your game. So that's also another thing why we decided to extend it. That's mainly it. Let's pass. I'm going to go to the before we continue, may I remind you that there is this page where you can, if you type book page, it gives you the link to the page with links if you want to learn 68,000 assembly programming. There are links to myself, of course, but there are links to others which are useful for learning, okay? I do not have every link out there. It's just for beginners to start, or for you to get you started. So yeah, and if you like it, comment below the page. Yeah, let's go to visual code, I assume, or you want to
Can we
start, or you want to
can
start
we
with.
start with the PDF?
Okay, we can start with the PDF. Um, there you go. So
I just want to do a summary for a presentation, nothing,
yes,
just
yeah.
a
So
this.
Ozzy is going to talk about his game, or the initial phase of his game, and then probably we will see it. But yeah, I leave it up to him. He will talk and talk and talk, and that's what I like about Ozzy, that he can fill up my stream.
Yeah, this time I have my bottle of water ready,
Yes, I was going
and
to tell you.
I'm not off guard this
Hmm.
time. Yeah, but before going into the technical details and coding, I like take take this episode easy and just relax and have a short talk about what I had in mind and what, let's say, what are my difficulties, why problems with the implementation, and what I would like to do because this is, I think, my first video game ever. I never programmed one before, so it's a new experience for me. I don't know anything about gameplay. I'm just a casual player. So this is why I came up with this. Let's say what I'm going to show you is just a proof of, and it was just my routines adapted to create a top-down to the car racing game. And please go to slide number 2, and you will find a screenshot of a game that I really loved back in the days.
Okay.
And
Um, Ozzy, permit me to say something which I forgot. Um, Guys, if you want to watch my stream, you can do it on Twitch, but downloading it and uploading it to YouTube, you will have issues because YouTube will flag it that you are breaking the copyright. So, guys, and it will take it down. Do not do that, okay? Because today I had this thing of somebody uploading my videos on YouTube, and I was flagged. Hey, do you acknowledge that this is copyright infringements? And of course I had to say yes because they were also on my channel. But YouTube will take them down, so please do not try to upload my videos on YouTube, okay? Or my streams on YouTube. Anyway, so let's go to the second slide. Here it is. Oh, I used to like this game too.
yeah,
Oh,
this is one of my more addictive games of my childhood, and for who doesn't know what it is, this is a game called Micro Machine or Micro Machine, like we say here in Italy. And what's the main feature here is that we have some cars, they are racing, and if one car, one of the challenger gets out of the screen, it loses points, while the first one gets a point. It's a very simple concept, and I like it a lot. What I don't like about Macro Machine is that, let's say, if you are the first, if you are the first, you can't see the road in front of you. You just have to go by heart. You have to memorize the track and memorize the timing. Maybe take some point of reference, but that's it. The problem is quite randomic because the guy who is in front of the race is the one who has, let's say, the it's harder for him to drive properly. So, but there is a very interesting and fun concept here, which is that if you press left, the car rotates counterclockwise. If you press right, the car rotates clockwise. There is the concept of acceleration. There is the concept of speed. There is the concept of drifting and braking. So all this stuff for me can be well represented with vectors. And actually, I strongly believe that the original programmers of Micro Machine used vectors for his game. I don't think another way in order to implement this type of logic. But what I don't like is the scrolling. So my goal was to get rid of the scrolling. So the whole track must fit on one big screen. That's it. And for this, probably I will need a high resolution. This is why originally I intended to implement all this stuff in chunky screen, taking advantage of the vampire, for example, which gives you a chunky screen, so you can use the rechargeable graphics library, standard graphics. But there are alternatives. For example, there is AGA, and AGA is quite good because it can go to high res and use 256 colors. And this is how I started. Since I've never done anything on AGA machines, and I don't know the AGA chipset, I just gave a brief look at the RunGen chapter, which is, I think, the last of the book, or quite late in the book.
Yes, it is.
Yeah. But the problem is, and maybe you can help me here, there is a particular example, I don't remember which one exactly, that did some magic, some black magic, and showed a high-res 256 color image on the screen.
Yeah.
And what I did, I just copy and paste this on and of course, I assembled with Plasma, and I run on FSUIE because it's my favorite Amiga emulator, and I get some weird behaviors. For example, the image is cut at the bottom, and part of it is at the top of the screen. So it's a very weird behavior. This is why I didn't have much time to investigate why it was working like that. I don't know if I'm doing something wrong, or if the emulator is wrong. I don't know. I didn't have time to try it on a real Amiga.
No, the emulator works, I can assure you, and the code works. I think in AGA you have to have the proper alignment, what is called alignment, and it's not just even. You have 32-bit and 64-bit alignment, and you need that. Believe it or not, the Amiga in 1992 was able to transfer from memory to screen at 64-bit, and you need to make sure that you have these options.
It is on. Still, I have some troubles, but anyway.
No, not just the option, of course. I'm saying it's one of the options, but you need the alignment, because as the image will be fragmented, it will be like, I don't know, cut it in pieces. I don't know how to explain it, but it's like cut.
Yeah, it's cut at the bottom of the screen. In my case.
I haven't seen what you have, but it could be, yeah.
Yeah, but I don't want to talk about my failures right now. Maybe later when you will look at my code, I will explain something more about this. But since what I was targeting is just to have a proof of concept of the physics, completely made up physics are realistic, I don't care. all I wanted to do it was just a physics engine that it was fun, and even if unrealistic, it was a lot arcade. So I want the car drifting a lot and taking some, let's say, strange behaviors because unexpected drifting for me is fun. So this is my goal, and what I started doing is prototyping on PJ5, and PJ5 is, let's say, a web version of processing, and it runs in a browser. And if you have my link, you can open your browser, so we can show what I did and what I try to translate to the Amiga. Because first I try on PJ5, and then I try to translate in M60A assembler.
So you want me to show what you did on PJ5?
Yeah, if
P5,
it's
sorry.
possible. PJ5 is
Yeah.
called. The website is pj5.org.
Yeah. Now it's going to be a little bit small, guys. Give me a second. First, I'm going to paste the link. So this is the game in P5.js. And
yeah, of course.
Yeah.
There is a lot to do. But the concept here is that you see there are three little dots on the lower left part of the screen. Yeah,
so,
and
let me try to zoom in. Maybe I manage. Yeah, you can see them, I guess. They're here. Look.
Perfect.
Yeah, you can continue.
Yeah, if you press play on the top right, the game starts, and what I wanted to show is that the three little dots. So the background image is a static image, and the static image is taken by a shareware game, a DOS game, which is called Rallycross, from an Italian guy called Fabio. And the idea is, of course, the collision are not implemented right now, and also the drag forces and the gravity is a little bit messy.
It's just a proof of concept, so
yeah,
that's why you see just the dot. But yeah, I let Ozzy to talk. I just want to say that it is a proof of concept, just in case people were wondering. And as you see, I'm not able to control it. I think he's a good Ferrari driver, Ozzy, because I am not able to steer so good as he does.
You didn't practice with Micro Machine.
Well, I played Micro Machine, but this is really skids.
Yeah, and for me the fun part is this, because the engine, the drifting is very strong, and it feels like driving on ice.
Yeah, exactly. That's how it feels. Actually, that's the right way of saying it.
Yeah, but anyway, of course, all the physics parameters can be adjusted to achieve the reality that you want. That's not the point right now. My proof of concept, it was just to demonstrate how I can implement the forces, so the acceleration, the concept of velocity, the concept of force, the concept of inertia. I don't know, is it inertia in English? In Italian, inertia.
Man, when it comes to Italian, technical words translated to English, I struggle. I always need to look them
Me
up.
too.
I always need to look them up.
But anyway, the first thing that I want to say is that, as you can see, I didn't mm, I didn't use the picture of the car. I used three dots, and this is why, because I want to think of a car like a bicycle, because it's easier for me to think with a vehicle with just two wheels in terms of collision detection and in terms also of let's say heading vectors and a lot of stuff. It gets a lot simplified, and I don't need the realistic physics of four wheels. So this is actually a bicycle. It's not a car, but of course, in my mind, when the project will be terminated, we will have a Formula One car here. The red dot is just a representation of where the front wheel will be, and the blue dot is the back wheel or the rear wheel. I don't know how to say it in English.
Yeah.
And the big green dot at the center is what I call the car position. And for me, the car position is important just to know where to draw the car, but the wheel position are important as well, because I want every frame, I want to check if the front wheel is in the asphalt or is in the grass, because the speed must change accordingly. And of course, I must change if you are hitting something, another car, or maybe some, let's say, some walls that are put around the track. And the same stuff for the back wheel. If you try to hit the border of the screen, there is a small proof of concept of how to behave if you slam into a wall. So just take the
I
speed
saw this
and
already. Yeah.
yeah, exactly. This is the concept. I just invert the velocity, and this is very fast calculation, even on real Amiga. Of course, it's not realistic, but for me, it can work at least for now. Of course, there is always some space to improve. And of course, this code is public. Anyone can try to change it, to modify. It's quite short. I think it's just a few hundred of lines. That's it. The only thing I want to say is that again the track image is taken from Rallycross, which is a DOS game. So don't take offense because I don't know, PC users and Amiga users are not going very well together. But yes, this game was very fun, and I want to achieve, let's say, something similar. Of course, I don't want to steal or copy the graphics. This is just a proof of concept. But I want to, let's say, given an image, I can draw with the deluxe paint the track, and then maybe in the OCS version, I can check if the sprite of the car is colliding with the color gray, and if it is, the velocity is at maximum, and then if it's colliding with the green, then I can halve the velocity. This is one possibility, or just make a mask of this track and compare the wheel position with this mask. This is another option, but I didn't decide yet. So yeah, that's it. Of course, as I told you, if anyone can play with this or help me implementing this on assembler, it's very welcome, because I put all the code on GitHub, so pull requests are very welcome. Okay, I think we can go back to the PDFs. Okay, let's go to page number 3. And yeah, now I will just repeat what I told you before. For me, a car it's a two-wheel object instead of go four like a bike. We have a front wheel and a rear wheel, and this simplifies things quite a lot for me, at least. Um, of course, my assumption is that the both wheels must have always the same distance from the center of the car, and the center of the car, which was represented with this big green dot, I will refer to it with the name car position. So all my variables and labels that refer to car position, they are actually the green dot. And the back wheel, the front wheel, and the car position will be represented as a 2D vector. So again, it's just a couple of XY coordinates, and of course, I need some decimal numbers here, and I would think them as a float or double primitive. That of course we don't have it in assembler, in Amiga assembler, but we will see later how I implement. Okay, you can turn the page. And by the way, did you download my code,
Yes.
the assembler code? Because
Yes.
I did a little change this morning. Did you fetch the latest changes
No.
tomorrow
No.
morning?
No. Definitely not.
Okay.
No. Definitely not.
Uh,
What you sent me yesterday, and when I told you I tested it, that's what I did, because the rest, as you know, I was working like you, so I couldn't do anything.
okay, but you have a Git client installed on your PC, I assume.
Yes, but I didn't do it through Git. I just don't know, because
Oh,
when I did it through Git, okay, when I did it actually through the download that you sent me, okay, because you're using links, AProcessing did not download. So I had to go and get AProcessing.
okay. Never mind. Maybe after we have just to copy and paste a file and that's it.
Yeah, I
Don't
mean,
worry.
let's continue, and then maybe I will get it while we are. But
Okay.
yes,
So let's continue, and here I will start to go a little bit technical because I just want to talk about my my problems with the implementation of assembler. And the main problem is my first problem, let's say, is that when you do thing on processing or PJ5 or any other, let's say, high level language or modern language, well, you have this concept of class. So what I did on PJ5, I just created a new class and I set some properties. Some of them are private, some of them are public, and then also there are these fancy stuff in Java, for example, that are protected or friend of C++, but that's another story. But I don't have this concept on assembler. So what I did, I just wrote this page and I listed what property a car should have for my game. And for each property, I want to state which primitive or which compound data structure statement is appropriate. And of course, the first three properties that I had in mind were car position, so the green dot, the velocity, and which is the representing the velocity of the car, so toward which direction are we heading, and the acceleration. So acceleration, again, is the change of velocity over time. And this is not something new. We already saw all these concepts in previous episodes. And I decided that these three properties must be represented with 2D vectors. And I will reserve 6 digits, 6 bits for the decimal part, as always, as usual. So 1 bit for the sign and 6 bits for the decimal part, just to represent float numbers. I want to state, okay, this, for example, this vector is x 0.5 and epsilon 0.5, and that's it. Then I said, okay, I want a wheelbase, and the wheelbase is the distance between two wheels in pixels, and it's 2 bytes outside the word. And of course, if you use a high number, it will be something like for a truck with the wheels which are very distant. And if you use small numbers, you get some. The three dots are very near to each other, very close. Then another property that I thought would be helpful is the steering angle. So how many degrees the car can rotate at each frame. Of course, if you say, if you give a high value here, the car will be steering very fast. So it's very agile. And if you go with the small numbers, it will take a lot of frame to perform, for example, a full 360 turn. The heading I put in red because what is marked in black is something that the user, as the programmer, can tweak according to his own tastes. And what's in red is the equivalent of a private member. So the user should not touch these properties. Of course, in assembly you can do whatever you want. There is no concept of private member, but here it was just a reminder for me that the heading vector can be changed only inside the, let's say, method of the class, which is my internal function, my internal routine. For now, I'm not using the heading, but I'm planning to improve the engine in the future, and I will, of course, need the heading vector. And of course, we need a steer direction, and which is telling us where the car is pointing, and it's in degrees. So I'm not using radians, I'm using just normal degrees. For me, it's easier to compute on the Amiga because I don't have, let's say, for me, it's easier because if you use degrees, you can just say, okay, I have this integer number and I can go into a lookup table quite fast. Okay, you can turn the page. We have some other properties. Okay, we have the forward vector, which is, for me, it's the most important one, which is the normalized vector of where the car is heading. We have the engine power, and this is just a number. And it just tells how powerful is the engine, of course, so how fast the car can reach the maximum speed. And of course, we have the maximum speed that just I use it to limit the velocity vector. So if you don't use a maximum speed, you will see the car is accelerating toward the infinite and above. So I needed to put a limit, of course, because the car will be too much unrealistic. And then I have three flags. And the most important one is the last one, which is colliding. And I need this for a lot of reasons. But for now, the main reason is that if the car is colliding with something, I revert the velocity. But after reversing the velocity, I have no guarantee that I'm not no more colliding. So without this flag, the car could be stuck in one point, just changing the velocity vector over and over again, and there would be no way to get on track. So this is why I really need this is colliding. And notice that even if they are just flags, I could use just a byte or a bit, but my experience told me that every time that I use a byte, I get some crashes because for my mistakes I go into odd address, and when you go into odd address, the old Motorola will complain. So for now, I will just say always using even memory address. So this is why I'm wasting so much bytes, 6 bytes wasted. But for now, it's good. Probably I can optimize later. And then, of course, it's accelerating, it's braking is just like that. Are telling the instance of the class, okay, the user press the accelerate button, so we are accelerating, and we must apply the force to accelerate to the velocity. And this braking is exactly the opposite. I think braking, is it correct? So it's like decelerating brake. I think it's correct in English.
Yeah,
Brake.
braking. Yeah, it's correct, yes.
And the pronunciation is just the same as to break something, like to crush something.
Mm-hmm.
Okay, good to know. And then I have this break coefficient, and then just state how much we can break each frame. So if the brakes are strong or if are quite let's say weak. And then we have please turn the page. We have the last page of this very boring list.
You want me to turn the page?
Yes, please. Yeah, we have the friction coefficient because I realized that if you do not press accelerate and you don't press the brake button, still your car must slow down. And this is because I imagine there is this force called gravity, which is pressing the car on the road. And so anyway, I just want the car to slow down gently, and the friction coefficient is very similar to the brake coefficient. It's just a lot weaker, but I think it helps to make the physics more realistic. And then last but not least, we have the back and the front wheel vectors. And these vectors are computed each frame according to the position of the car and the orientation of the car. So I marked these two fields in red because I don't want the programmer from the main function to change these values. These values must be computed from a particular routine each frame. And I want to make sure that the distance between the back wheel and the center of the car is equal to the distance from the front wheel to the center of the car, so that the car more or less gets quite realistic. Okay, can we please turn the page again? Okay, this is, let's say, my initial assumption. There is a double arrow, and I call this wheel distance, which is the property I was talking about before, which is the distance between the two wheels expressed in pixels. And I say, okay, there is a car position, which is exactly in the middle. So the idea is that each frame, my game must take the car position and where the car is heading, expressed in degrees, and then add the vector, the heading vector, to the car position, and subtract the same exact vector to the car position. And this should give me the front wheel and the back wheel position. And the math involved is just in this the lower left corner of the page. There is exactly a copy and paste of what I did in PJ5. Of course, I can't do this on assembler. I have to use my routine, so the mul instruction. But the idea here is that the front wheel vector is the vector which is calculated using cosine of the angle and the sine. So this is just another way to create a vector, because in the previous episode, when I created the vector, I said, okay, this is x and this is y. And then the routine computes the angle and the magnitude, all this fancy stuff. Now it's a little bit different. I want to create a wheel vector from an angle. And the formula is to use just cosine and sine. This will give you a normalized vector, which is pointing according to the car heading value expressed in degrees. And I hope this is quite understandable for you. And once I have the front wheel vector computed, I just do a vector addition. I say that the wheel position, the front wheel position, is the car position. And of course, you have to divide by 2 the vector, because the wheel distance is representing the distance from the front to the back. But I want to add the vector from the middle of the vector, from the car position. This is why I have to divide by 2, which in assembly is just a right shift to the right. A right shift. And then, as I said, I just add these 2 vectors, and I get the front wheel position, and the same stuff is for the back wheel position. The only difference is that this time I have to subtract, but the concept is exactly the same. And if you want, I can show this. Oh, I think in the next page there is the translation, so you can go to the next page, and we will see how I translated all this stuff. Okay, this is where just the reference when you can find the implementation. I think you can just go to the next page, and which is the translation. Yeah, this is what you will find in the link I gave you in the previous page. Let center to the wheel equal to this dot forward vector dot copy. So on the left side of this table, you find the PJ5 code, and on the right there is uh, my assembler M68 assembler translation that you can find on GitHub. And for me, the copy of the vector is just a move.l, nothing more, nothing less. I don't have a routine for this. Just to instruction, you load into A1 with vector, and then you just copy all the contents of the forward vector into A1. So the address pointed to A1. And moving forward, vector offset is something that is implemented. It's just a directive. Maybe we can show this on the code. If you have Visual Studio Code open, you go
Yes.
to rc.s
Wait.
file.
Yeah, and where do you want me to go?
There is a file which is okay. This one is
Yeah.
rc.s, and if you go to the top of this file, you should find a big list. Okay, this equal directive, and this is what I usually do to represent a data structure. I just take the offset from the base of the data structure, and it was just to show how the data structure is done. So the first one is a 4-byte vector. It's the position vector. Then we have the velocity, and then the acceleration. If you see, I go 4 by 4 because each vector takes 4 bytes. And then I start using words. So 8, 10, 12, 14, 16, 20, 22, and so on. But anyway, if someone wants to contribute to this project, of course, just send me pull request. I'm not joking at all. If you find bugs here, just submit a pull request on GitHub. I will be more than happy to merge it. I forgot what I was saying. Okay. So this is how I navigate through my car data structure, and I use this offset just to get to the right position in memory. So, for example, if I want to set the velocity offset, I just say move.l, and then I state the number that I want to set, and then I say mover velocity offset, and then A1, A2, where A1, A2 contains, of course, the base address of the car. And this is how I usually do stuff. I don't know if it's correct or wrong, but just my way of doing things. So, okay, please go back to the PDF. So, I translated the copy function into just a move.l, and using the the same exact method that I described before. Then I must scale the vector according to what? According to wheelbase, so the distance between the two wheels expressed in pixels divided by 2. Just remember what I said on the previous slide. And I implemented this with the following code. So load the entire address with vector 1 into A0. So this is the memory location into A0. And then I put the wheelbase, so the distance in pixel into the 0. And I do this because I want to do the division. I want to divide by 2. And of course, I'm not using divs or divu, but I'm just using LSR or ASR would be the same because I'm using positive numbers. And then I just put back in memory, pointed by 0, the value. And then there is this new macro, which is a macro move to the vector 1x2. And this is very similar to the regular move to the vector. The only difference is that with this macro, you are multiplying a scalar value, like for example, the wheelbase divided by 2. You are multiplying this value with a vector, and the result will be into A1, so the second one. And this is how I scale. I could have used set magnitude, but it doesn't make sense because the forward vector copy, if you recall, contains the normalized version of the vector. So you don't need to use a set magnitude and to do extra stuff and extra calculation. Our poor Amiga needs very lightweight code. And so I figured out this new macro, and this macro was implemented into AProcessing. And I think it's the last thing that I did on AProcessing. And of course, it was tested. We just did a couple of tests. And it should work because it's just 3 or 4 instructions, nothing very heavy to compute. Of course, there is a mult inside, and the mult takes time, of course, but I must already, I have to use mult to multiply a vector. And then on the third row, I do the vector addition in order to compute where the back wheel is and the front wheel is. So it's the third and the fourth row. What I do is just I point into A0 to the back wheel vector, and then I copy the position here because I want to add this vector that I calculated before with the position of the car. So in A0, I just copy again the position of the car, and then I put into A1 the wheel vector, and which is the outcome of the previous vector multiplication. And then I call sub2d vector static. And if you recall the static version of my macros, they require a parameter because the outcome of the operation is subtraction will be stored not on the second parameter, but in the parameter you feed the macro with. So The same concept, of course, applies to the for the front wheel. The only difference is, of course, that you have the add 2D vector static instead of sub 2D vector static. And you can just, if you want to, you can go back to the previous page and copy and paste the code into your browser, and you will see exactly what I just explained.
Which one? Which one? So I am here.
No, the previous, go back. This is the last page.
Ah, sorry, yeah, here. Yeah?
I said the previous page.
Yeah, this is last.
Yeah.
So this is number 9, and this is number 8.
I'm seeing with some delay on Twitch, but it's the where I say ASM translation, https github.com, Ozzyboshi blog main POCS calculating
This
position.
one. So this one.
Yeah. Yeah.
Okay. Guys, may I remind you, this is about the game jam. Okay, so Ozzy is participating in the game jam with his his game based on AProcessing as always, and here is the code that he was talking about.
Exactly.
If you want to help him, you can join
not...
him, basically, also, right? Actually, let me put it in the chat. Let me put it in the chat. Okay.
Perfect.
So, shall I go to the PDF?
Wait a moment. Just click on artsy_OCS on the title. So I can, maybe it's better if you go to Visual Studio Code. We can watch this on Visual Studio Code.
Here?
Please go back to Visual Studio Code. And go to line, go to line 100. Let's see. Okay, go to 164. And this is the main loop of the game. So this is where all the magic happens. And as you can see on line 163, I have it starts an iteration, because in my mind this stuff should occur for every car which is challenging in this race. And for each one, I would say my intention is to read the inputs. For now, I just use the Leggy joystick. You may recall this function, this routine, because it's a copy and paste of RunGem adapted. It just puts into the zero the movement of your joystick. Then you have this manage input routine, which just changes the internal state of the mover object or the car object. The mover is the same as car in this context. So, for example, if you press up, what it does, it sets the Boolean flag is accelerating to true, and this will tell later the engine that the velocity vector must be incremented according to the acceleration vector. And then I call applied friction, which is my gravity simulation. Then I call accelerate, which is what I was telling you before. It's just adding to the velocity vector of the acceleration. If you press brake, of course, the brake routine will take care of this. And then there is this .w move. And this function will in turn will calculate the distance, will evaluate the position of the car and will add the vector in order to calculate where the wheels are. So this is where I use the calculated wheels function. It's inside the move. So the move function is just all it does. It just says, okay, this is the new position of the car because you press and accelerate, for example, or because you brake. And then I check for collisions, and collisions for now are just the border screen. So if you are trying to go outside the playfield, it will prevent you in some way. It doesn't work very well for now, but we try to prevent you from going outside the screen. And then I have the display function. And the display function, what it
Thanks for
does
the
is
raid.
just to read the vector, the position.
Remember, guys, we are talking about. Actually, let me show it because that's the best way to do it. No, we are. Where is the browser? Yeah, we are talking about this game jam. Okay, so Ozzy is participating in this game jam and he is showing the theory behind his game. Okay, for which if you permit me, there you go. You can see his implementation as proof of concept. So this is not on the Amiga. This is using a modern high-level language to have his game, testing his mechanics basically. And now he is showing it on the Amiga, the same mechanics. We're going to see them on the Amiga, and he's explaining the code. This is where we are. I don't know if you can see the dot. Yeah, I hopefully before, and you can see these are the mechanics related to the game. There is no collision detection yet, but the skidding on ice is there. That Ozzy likes a lot.
Yeah.
So
The most
anyway,
important part is skidding.
yeah. So yeah, that's the where we are right now. I'll continue. I'll pass back to Ozzy. The code is available, and I will share it while Ozzy is talking. So let's go to Visual Code.
I just wanted to say one thing, and I don't know if you noticed, it's possible on my proof of concept to rotate the car even if velocity is zero, and this is a lot unrealistic. And but anyway, of course, it's easier. It's very easy to implement this if you want to get rid of this behavior. One of my previous version was stating that if the magnitude of the velocity is less than, let's say, one arbitrary value, you just disable the steering function, and it's quite easy. It's inside the manage inputs, but I thought why I would do that. I like turning the car at velocity zero. So even if it's realistic, it doesn't matter for me. It's the game must be fun, not realistic, of course. So this
Um,
is
uh,
why you are able to turn on a dime in my PJ5 implementation.
the the art the B art Arasti. I cannot say it. Sorry, the Barasti. It's Emilio. Thank you for the follow. Sorry, I missed that. So yeah, thank you for the follow. Sorry, Ozzy.
No, it's good. I just wanted to state clearly that this turning on a dime it's not bug. It is something that I want because I like it, even if it's unrealistic. And this is something that I want also in the Amiga version. So because of course someone could think that it's impossible to steer what velocity zero, of course. And I think also this this can help if the car hits a wall on a dead end. Maybe it can help to be back on road quite easily. And also I have to implement the rear gear right now. That I think it's you can only go forward, you can't go backward. I know why this happens, but maybe I can say to the game if you keep press braking at the velocity zero, the velocity vector must be negative, and this should move the car forward. But this is an implementation that it's possible to do. And of course, if someone wants to do it, be my guest. So let's get back on the code. So I think there's nothing more to say to this movers loop. I was telling you that the display function is just taking the position vector and the front wheel vector and the back wheel vector. And on the current implementation, it doesn't draw a sprite, an image, it just draws dots because for me, these are still early stages of the project, and I prefer to see a dot instead of a car. And I don't want to see the track on background. I just want a black screen that it makes me realize if something is wrong or not. And of course, after the display function invocation, I just add to A0, which holds the base of the car data structure. I just add its own size to iterate into the second car and the third car and the fourth car and so on. So this bunch of function will be executed for each car. Currently the loop is one, so it's not an iteration of course, because there is only one mover object in the screen. The others can be implemented, but implementing AI on this game should be quite hard. What I thought it was something like that. You draw the track, and then you just make one lap. One human player just play performs a full lap, and then the computer should record what you pressed and the points that the car is traversing during the lap, and store them. So do this more times, and then just store it somewhere in a file, for example, and then like the computer AI could fetch this data and try to compute the trajectory of the car over and over again. So the main idea is to reuse the data of a human player in order to teach the computer how to drive on a particular track. This is quite difficult to implement, I know. For now, I just want my car, a human player to drive,
Good
and a
luck.
timer. And your goal is just to perform the full lap in best time as possible.
Yeah, good luck.
Uh,
That's a tough job, I think, to make it AI like that.
but I don't think it's so impossible. Of course, there will be bugs. I expect, for example, if you hit a computer car during the race and this computer car goes into a dead end, I think it will be quite difficult to get on track. I think I should add some more logic, so it's not easy. So for me, the most difficult part to implement will be this. But for now, I really don't care. I just want one
Sure.
human player, maybe two,
Yeah,
two
I
joysticks
understand.
or a keyboard, and that's it. Just
Mm-hmm.
competing on a race. And another thing that I really want to do is just to have different. The car should behave differently according to the part of the track which is traversing. For example, if you get on ice, I want the road to be very slippery. And if you are on asphalt, everything is fine and you reach maximum speed and maximum traction. So these are my main goal. I really don't care much about the computer AI at this stage. Maybe in the future, maybe someone will help some better ideas. I don't know. For now, I have also problems with this collision detection because I don't know how to do that. As I told you before, my first guess was to reuse Amiga hardware acceleration because Amiga gives you the possibility to detect if a sprite is colliding with a particular background color or a particular bit plane. So my first guess was, okay, I just draw the track on a bit plane and each car is a sprite and it can be very limited because I can only draw four cards in this with this method because the Amiga has eight sprites, but the sprites share the same color. So okay, if I do the card of one single color, I can end up with eight different cards, but for now, two cards is what I'm looking for. So my first guess would be a car will be implemented in sprites, so the dots that you see will be replaced by sprites. And then I detect collision with this hardware detection. But there is a downside because if I try to port this on RPG, I don't have this hardware acceleration available on
Mm-hmm.
RPG. I have to do the math on my own using the CPU. And this is why sometimes I feel when I try to do something on the chunky screen on RPG, it feels like programming a PC. It's much more closer because for this particular task, you can't uh, take advantage of the chipset for collision detection. But on the other side, you have a powerful CPU and powerful RAM timings. So uh, I don't know. If I want to do this multi-platform, let's say one RPG version, one AGA version, and one OCS version, maybe I should take another approach. But really, I don't know. I'm just improvising. I don't know if, even if what I'm stating is right or wrong. Okay, so let's go back to the PDF. I think I'm approaching to the end.
Yes, that's the last slide.
Oh yeah, last slide.
Okay, I'm going to put all
Uh,
these in the chat. So uh, for those that want to have a look.
Yeah, just again, please let me repeat the the game that I would like to recreate. Of course, it's not a ripoff. I don't want a ripoff. I just want to take inspiration. I don't want to steal intellectual property. I don't want to copy assets. I don't want to copy tracks, images, music, sound effects, and so on from this game, which is called Rallycross. And again, this is a shareware DOS game that I bought because I remember I took a letter and I put cash inside the letter and sent it to the shareware author, and he replied with another letter with the four DOS floppy disk, and I had a Pentium 65 at that age, and I've had a lot of fun with this game, which is called Rallycross, and you can play it directly on your browser today, thanks to archive.org. But again, I want to achieve something similar on the Amiga, and I would like to achieve it on AGA because I like the high resolution for this game. I think it fits well, very well, and going low res on I don't think it's the way to go. But for now, I'm just using OCS, so that's what it is. And again, if you want to just change a byte or correct something, or you find something stupid, or you just want to contribute to this game, I'm very open to anyone. Just submit a pull request or get in touch with me. Of course, you will know how to find me on Discord or whatever platform. And of course, you have the PJ5 code, and you can tweak, and there is a constructor class. There is a car.js file inside PJ5, PJ5, and you can have fun just changing the values and see how the engine behaves. And maybe
Yeah.
you can, of course, you can reuse all of this stuff to make your own video game for the competition. I'm not saying that if you use this, you have to contribute on my particular port, but that's it.
I think we have arrived at the time when we need to show actually what we have on the Amiga, no? Because we've shown it on P5JS, but I think now that you finish the slides, no, unless there is more, we need to show what we have on the source.
Oh yes, I forgot. Yes, you can run it.
Because yeah, I need to run it, no? So
just one thing before you run it. If you go back to the GitHub page and you go to the root of the project, you will find two different folders.
So I am on. Okay, let me show you where I am, and then you tell me. So
okay,
I am on your. Of course, it will take some time to show it on Twitch, but I am on your main page here. Yeah.
Wait, I see Visual Studio Code. I don't see the browser.
Hold on. There you go.
Okay, there are two folders.
Yeah. We go on OCS.
OCS version, of course.
Mm-hmm.
The AGA
Ciao,
version
Pellicus.
is
Ciao,
not
Dario.
implemented.
Sorry, where?
Let me start again.
Mm-hmm.
So you are on inside artsy underscore OCS,
Yeah,
and artsy OCS is what I showed before, more
yeah.
or less. Okay, but my first goal was to implement all of these in high-res 256 colors to add
Yeah.
VGA-like modes on
Mm-hmm.
AGA. So if you go back to the previous page, to the root of the project,
Uh-huh.
and if you go into the AGA folder,
Uh-huh.
there is what I was telling you before.
Mm-hmm.
This is lezione 15
D.
i.s,
Mm-hmm.
and what I want to do here, this is just a copy and paste of RunGen, first of
Mm-hmm.
all. I just changed the image.
Mm-hmm.
Uh, and this is what I get. So the image it's centered in the bottom of the screen, and the lower part of the image is shown on top. So like if there is some synchronization problem, I don't know. But my goal here is to take all the ACS physics calculation that I did
Mm-hmm.
and copy and paste here and do the game in AGA. So this is, let's say, the ultimate goal that I will never achieve. This file, as I told you before, is a copy and paste of RunGem, and I expected to work properly, but still it fails on FSUIE, and I don't know why.
Is
Pardon.
this the image of RemGem?
No, the image is the very same image that I took from pj5.js.
Uh-huh.
It has been converted into raw, and the
Here,
colors are not right still.
here it's saying 640 by 100.
Yeah, exactly. It's 100. Uh, yeah, the problem is that even if it's 100, I see the image is not displayed properly, and I don't know. Uh, I think there is something wrong with my emulator, because really, it's really the
Okay.
program is a copy and paste from RunGen. So
Yeah, but
if you have any feedback,
is this the one that RemGem uses with Hem 8?
uh, mm, mm, this
Because
is leftover.
I'm seeing this here. This is a Hem 8 image.
Yeah, but it's not used in the project. It went into this repository by accident, and I have to
Uh-huh.
remove it. What
Okay,
the
we can look
project
it
is
after.
actually using.
We can look it afterwards. Okay. Uh, I mean, on mine it
Uh,
works. Okay, 15i works. Let's put it this way.
yeah.
and
Okay,
and
so I
same for
think now you.
15d.
Yeah, exactly. But anyway, we can talk about it later, and
Yeah.
or I will work again the next weekend on this, because what I want to do is take the image from pj5.js, the very same image, convert it to raw, and I don't have any software capable of doing this, because all my conversion software uses OCS. They are able to convert PNG into OCS images, but this time I want a high res
Yeah.
156 color, and I don't have anything.
Okay. So let's do the first thing. Let's run your game.
I don't see the emulator.
No, no.
Oh, yes.
Wait. It's still loading. Bless you.
But I have a cough today.
So you have your three dots, and you said it needs the joystick, no?
Yeah, use the joystick, move up the joystick to accelerate and move down to brake.
Yeah, yeah, I can see. Ew. Now remember, the blue dot is the center of the car, the red is the front wheel, and the green is the back wheel, no?
Yes, uh, still
And
the movement is not fully implemented. There are some flaws, so it's not behaving exactly like the PGI5 version. But
it's
still, I have something moving on the screen, so I'm very happy of this. And you can also try to hit the walls. You should
it
see
breaks.
the background that changes color. This will indicate that the velocity vector gets multiplied by -1. So I'm just
Uh-huh.
changing the sign. So we have this collision detection, and of course, it's not done with hardware. It's not hardware detected. It's just at every frame, I just check if the red dot is at position greater than 320 or -0, and in this case, I just reverse the velocity.
New.
So what
Anyway,
I
I like
what
I
I need
like it. I have to say, even though it's dots, I like it. And for me, it's controllable better than what's on PJ5, P5. Sorry, JS. It's I'm able to control it a lot better than what you have on. Uh, I mean, it's obeying better. Let's put it this way, to the movement of what I
yeah,
want.
the major problem here is that since the resolution is so low, you end up doing the full lap in just a few moments.
Yeah, but
So
uh,
I thought that doubling the resolution should improve a lot this concept.
guys, thank you very much. I hope you have a lovely week and see you wherever I stream again. Hopefully Friday and in the weekend. Anyway, guys, thank you and bye bye.